Hello, hello. Welcome to lesson two. This time we're going to learn about specifically the Earth and the Moon, not so much the planets. That's actually going to come a little later. So let's get into section two. The Sun, Earth, Moon system. So if the Earth is a planet, then we know it follows all those rules that planets do, which means the Earth orbits the Sun in a path that is an ellipse. I missed a word there. I should say the Earth. Earth is closest to the Sun in January and farthest from it in July. Now some people are thinking, wait a minute, January is when it's winter, but it's the closest to the Sun? That is correct. How close the Sun is to the Earth does not determine seasons. Because if you also think about it, if it's winter in the northern hemisphere, that means it's summer in the southern hemisphere. They're opposites. So it doesn't make sense that January be the hottest month because it's winter for us. So this doesn't line up. How close the Earth is to the Sun does not determine seasons. We know that while revolving around the Sun, the Earth rotates. How long does it take to rotate? What's its period of rotation? Well, we know it's 24 hours. It's just a day, right? The period of rotation is just a day. Something interesting though, Earth's axis of rotation is tilted at an angle of 23.5 degrees with respect to Earth's plane of orbit around the Sun. What that means is, if this is the Earth, it does not rotate around me straight like this. Okay? It's kind of bent like that. Can you see that? This is if it was directly in line with me, but it's not. It's bent a little bit at a 23.5 degree angle. Okay? This is actually what gives Earth the seasons. Which part of Earth is facing the Sun more often determines the season. So during our summer in the northern hemisphere, most of the time the top part of the Earth is facing the Sun, and the bottom part of the Earth, the southern hemisphere, is facing away from the Sun a little more. But during winter, the top part of the Sun is facing, the top part of Earth is facing away from the Sun, and the bottom part of the Earth is facing towards the Sun. So let's look at a picture like this. Can I pause this? I can't pause this. Okay, let's look at summer. If you look at summer, we are mostly facing that, while the southern part is facing away. Okay, this is why there are seasons. And this is why autumn and spring usually are kind of a mixture between the two, because for us, summer, we're going from hot to cold, and we kind of have an even amount of daylight. Same thing with spring, it's kind of an even amount of daylight. I don't know if you've noticed, but in summer, the days are actually longer. You see the sun more than it's dark during the summer. And during winter, it's dark more than it is light. I don't know if you've noticed that, but that is true. Autumn and spring are pretty even. There's actually a day during these when it is 12 hours a day and 12 hours a night exactly, but that's not always the case. During summer, there's more than 12 hours of daylight. During winter, there's more than 12 hours of darkness. Or evening, I should say. So you guys have probably heard about a satellite. The definition of a satellite is pretty straightforward. An object that revolves around a planet. It could be natural or artificial. I'm sure you guys know about artificial satellites. But a natural satellite is just one that already exists that we didn't put there. The moon is a natural satellite that revolves around Earth. We're not really sure how it forms. Scientists think that maybe a giant rock hit the Earth a long time ago, and the debris formed the moon. Scientists estimate that the moon and the Earth might be 4.5 billion years old. Some of you at home may not agree with that, but I'm just letting you know what the scientists have figured out based off of the way they determine the ages of rocks and stuff. It's 4.5 billion years old. This is called the giant impact hypothesis. So in addition to orbiting the Earth, the moon also rotates once every 28 days. Okay? What the interesting thing is that it rotates just as fast as it revolves. That's why you always see the same side of the moon. You never see the other side of the moon because as it's going around the Earth, the same face is always looking at you because it's also revolving with the same speed. But something you might notice is that there are different lunar phases, you know, like full moon and new moon and crescent moon and stuff like that. And that's because different parts of the moon are still facing the sun when we can see it. So if you ever cannot see the moon at night, it's either behind you or if it's a new moon, it's like this. All the lit up part of the moon is on the part of the moon you can't see, so the moon appears dark. But eventually it becomes a crescent. That's because as you're looking at it, this part of the moon is being hit by sunlight still. Here we see half and half. Here we see most of it's getting hit with sunlight. Here it looks like the whole thing is lit up because the Earth and the moon aren't perfectly aligned. So the moon is a little bit above or a little bit below, and it's still getting hit by sunlight. But the important thing to realize is that in all of these pictures, half of the moon is always getting hit with sun. We might not see it, but half of the moon is always getting hit with sunlight. It just depends on which part of the moon you can see. And of course, there's all these cool things that you guys probably heard of before, eclipses. An eclipse is a total or partial obscuring of one celestial body by another. Here we see the moon jumping in front of the sun, making this awesome picture for just a moment before the moon moves by. That's actually how fast the moon moves. You don't really notice it until you're trying to wait for that moment right here, and then it's gone, just like that. But that's how fast the moon is moving. So first, let's look at a lunar eclipse. That's what happens when the Earth is between the sun and the moon. That's when the moon gets all red and evil looking, but it looks really cool. And the reason why it's doing that is because the sun is going into our atmosphere. And you know how like at sunset everything looks like red and orange, right? And it looks really pretty. Well, that's kind of what that is kind of what is happening. Oh, my English got messed up there. That's kind of what that is kind of what is happening. Oh my gosh. That is what is happening in this case. The sun goes through our atmosphere, it makes the light all red, and then that red light gets thrown onto the moon. So we are essentially seeing the Earth's sunsets being projected onto the moon. And that's why it looks red like that. Pretty cool. Can only take place when the moon is full, because that means the moon is behind us, right? The moon, Earth, and then the sun. So the moon has to be behind us. The other one we got is the solar eclipse. That's what happens when the moon moves in front of the sun. Now the moon is way smaller than the sun, but the sun is a lot farther away, so they actually end up being about the same size. Almost exactly so. Almost like somebody designed it. So as the sun is shining light, it hits the moon. There's only like this middle part of the moon's shadow that gets hit with that really cool solar eclipse. The rest of this stuff still gets eclipsed, but this light's kind of bouncing sideways, so it still kind of lights up the outer portion of it. So you have to be in the direct path of the moon to be able to see that cool picture like this one over here. Otherwise, yeah, the sun does get dimmer, but you won't see that full cool picture that people look for. Unless you are in that specific path. Let's see if we can find that path. On April 8th, 2024, so in a couple years, a total solar eclipse will trace a narrow path of totality across 13 states. Yellow lines indicate the limits of the path of totality. Okay. The green middle line represents the eclipse center line. Okay. To experience a total phase of the eclipse in each state, you must be within the yellow lines. Cool. Okay. Oh, we can't rotate this? So if you want to go to Texas in 2024, as long as you're within this, you can see the full eclipse. Oh, that's cool. If you're in Dallas, you'll be able to see it. I have friends that live there, around there. If you're in Oklahoma, you might see a little bit of it. Arkansas, you see a decent portion of it. Missouri will see part of it. Illinois, they have a whole map. I'm gonna see everything at once. Here we go. This is what we're looking for. So if you're anywhere in there, you can see the actual total solar eclipse in 2024. But that seems to be the only one that's happening anytime soon. There might be one in other countries. And you'll see like these years, like we already know what's going to happen. That's because we've used math so much that like we know how these planets are going to line up and everything. We know when the next eclipses are. It's not like, oh, well, like the weather. Like, oh, it might rain tomorrow or it might not. There might be an eclipse. There might not. No, we have this down to like mathematical. We know the seconds in which these things will happen. Oh, wow, that is it. This is a short section. Well, that's it. Lesson 2. We are done.